Good afternoon to one another. This is Dr. K. Pushpa Rani, Associate Professor, Department of CSC, MLR Institute of Technology. In this video, we are going to discuss about the graph traversals. So, what is the definition of graph traversal? And we can understanding those traversal techniques by taking some examples. What is the definition of traversal? So, graph traversal is nothing but we need to search for the vertex, and traversal means visiting each vertex exactly once is called as traversal. But in the case of graph traversal, we have to start the visiting process from the root node, and we have to visit all the nodes exactly once without forming the loop. Loop should not be formed in the case of traversal. There are two types of traversal techniques in the case of graph theory. One is called as a depth first spanning tree. Second one is the breadth first spanning tree. So first one is a depth first spanning tree. In the case of DFS stands for depth first traversal. In DFS traversal, we have to do the traversing process, and we have to produce the spanning tree. So without forming the cycle. For that reason, we are using one stack data structure. That stack data structure consisting of number of vertices will be stored in the stack. What is the procedure we are going to follow for the implementation of DFS traversal? First step is we need to define the size of the stack. That is, the size of the stack is depends upon the number of vertices in the graph. Second one is we have to start the visiting process by default at the root node for the traversal, and the element where the point which is visited, that is push it onto the stack. Then visit any of the non-visited adjacent vertices which is at the top of the stack and push it onto the stack. So after that we have to take the corresponding adjacent vertices which are not visited. Again we have to push it onto the stack. So we need to repeat this process until there is no new vertices to be visited. If it is a new vertices, we need to use the backtracking and come back to the previous position, and any unvisited vertices are left, again we have to visit and push it onto the stack. Repeat these steps 4, 5 until the stack is empty. When the stack is empty, then we have to constructing the spanning tree by removing the unused edges from the given graph. So consider the following graph. We have to perform the DFS traversal. Step 1, we need to use the stack for maintaining the list of elements which are pushed onto the stack. That means first you have to start the visiting process from A. A is pushed onto the stack. Total how many elements are there? Total 7 elements are there. We have to push first element of A, that is A. Then after A, what are the adjacent vertices? B and D, or both are adjacent. But we are going downward, so we have to give the importance to T. D is push it onto the stack. Next, D adjacent is E. E is push it onto the stack. Next, E adjacent is B, F, C. Then we are always give the preference to the, that is lower part only. We have to push F onto the stack. Next, F adjacent is G. F adjacent is G. Next, G adjacent is C. Next, C adjacent is E. C adjacent is E and also B. Then, so we have to take C adjacent is B. Next, B adjacent is A. It is already visited. No need to visit. B adjacent is E is also visited. No need to adjacent. Just to pop it from the stack and print it. Next, C. C adjacent is already visited. B, C, G. Then after that F, then E, D, A. This is the DFS traversal. If any unvisited vertices, we have to go back and we have to visit the leftover unvisited vertices and print the corresponding DFS traversal. Now find the DFS traversal for the following graph. So we have to start the visiting process from A. What are the adjacent vertices of A? D, G, then E. But we are going to give the importance to downwards. Then next vertex is D. After that D, C, Z, B. Next one is C. We have to visit each vertex exactly once. Next G, B. We have to take C to B. B, then E. You can visit any one. E. After that E adjacent is F. F adjacent is G. So we need to check whether any other, so here it is a form the cycle. So we need to go back. So after that we need to should not form the cycle. So first you have to start the visiting process A to D, no cycle. So we have to going down. D to C does not form the cycle. C to B, no cycle. B to E, no cycle. E to F, no cycle. F to G, no cycle. So there is no cycle. So what is the visiting order of DFS traversal? We have to concentrate on the downwards. A to D, D to C, then C to B, B to E, E to F, F to G. All nodes are visited. This is the corresponding DFS spanning tree. Depth first spanning tree. Next traversal is BFS traversal. That is a breadth first search traversal. So we can also, this is also called as level order traversal. Level order traversal. So in the case of BFS spanning tree, we are going to give the importance for the level by level. So first we have to visit all the levels in the first level. So go to the second level, visit all the adjacent vertices, then you have to go for the third level. Like that we need to repeat the process to visit all the visited vertices, unvisited vertices. So if any vertices are not visited, you have to go back and then visit. So for the BFS traversal, we can use Q as a data structure for maintaining the list of visited nodes. So we need to define the Q of size, that means total number of vertices. We need to start the vertex, that is called as a starting point. The vertex which is visited can be pushed onto the stack and visit all the unvisited vertices of adjacent vertices. And if it is no new vertex to be visited, then we have to delete the front element of the queue. Repeat this process until the queue is empty. Once the queue is empty, we have to draw the spanning tree for the following graph. Consider the same example. Then we have to take the queue of size, that is 8. 1, 2, 3, 4, 5, 6, 7, 8. Next, A is pushed onto the stack. A is pushed onto the stack. So we need to draw A. So after that, before deleting the element of A, we need to insert adjacent vertices of A. That is, B is adjacent, D, E. Delete the front element of the Q, add it to the spanning tree. Next, B is the next adjacent vertex that is visited after A. B is the next unvisited vertex. B is added. Next, before deleting the front element of the Q, what are the adjacent vertices? So B, E, it is already added. Then C is added to the front element of the Q. Next, D. D is deleted from the queue and added to the spanning tree. What are the adjacent vertices of D? Adjacent vertices of D is A and E. A and A. So that is already visited. No need to visit. No need to visit. Next, what is the next front element of the queue? E. E is deleted from the queue After D is visited, what is the corresponding adjacent vertices of E? A. It is already visited. Then C is already added. F is added to the Q. Next, what is the next adjacent vertex? C. C is deleted from the Q. Then what are the adjacent vertices of C? B, E, F, G. F is already added. G is added to the Q. Then what is the next one? C is added. Next, delete the front element of the Q. After C, visiting order is F. What are the adjacent vertices? All are visited. E is visited, C is visited, then G is already visited. So no need to add the remaining vertices. Next, what is the front element of the Q? That is G. So G is added after F. Then what are the elements of G? All are added. So this is not the total number of vertices are 7. Now all the elements are deleted from the Q. Once the Q is empty, we have to write the corresponding BFS traversal. What is the order? First of all, A is deleted from the Q. A, B, D, E, C, F, G. This is the BFS traversal for the following graph. So what is step 1? How to start the visiting process from the first vertex and write the corresponding adjacent vertices into the Q. Delete the front element of the Q before adding the adjacent vertex of the second vertex. Repeat this process until the Q is empty. Once the Q is empty, we have to write the corresponding BFS traversal. Consider this following graph. Find the BFS traversal for the following graph. So what is total number of vertices? 1, 2, 3, 4, 5, 6, 7. So the Q size is also 7. Next, first of all, A is visited. We have to start the visiting process in any order. A is visited. The vertex which is visited, that we have to draw the spanning tree. Next, so before deleting A, what are the adjacent vertices of A? G, E, D. So write it in the order. First of all D, then E, then G. Then delete the front element of the Q. Next, what are the next element is D. We have to draw the spanning tree from A to D. So before deleting D, what are the adjacent vertices of D? That is, one is C, another one is G. G is already added to the unvisited vertex. C is added and D is deleted from the Q. Deleted from the Q. Next, what is the next one? That is E. E is added. So A to E connection is there. And before deleting E, what are the adjacent vertices of E? So write it in the order. That is G. G is already over. Leftover vertex is F and B. B, F. Write it in the order. Next, after that, the next adjacent vertex is G. So next adjacent vertex is G. So in the case of G, so what are the adjacent vertices of G? F. It is already added. E is already added. B is already added. C is already added. Just to write the corresponding vertex. Next, what is the C? Next vertex is C. C is the next vertex, and after G, C is the next vertex. So what are the adjacent vertices of C? G, B and D. It is already included in the spanning tree. Just remove it. Next, after the adjacent vertex is B. C to B. What is the visiting order? B adjacent is G. It is already included. E is already included. C is already included. Next, just delete from the Q. Next, F. So F can form the cycle. So F is deleted from the Q and you have to draw E to F. E to F. This is the corresponding BFS traversal for the following graph. So we have to start the visiting process from A and we have to insert the adjacent vertices of A and repeat this process until the queue is empty. Once the queue is empty, so then we have to draw the corresponding spanning tree for the BFS traversal. So what we have discussed up to now, what is meant by traversal, what are the different types of traversal, that is a BFS and DFS, and we can understanding those traversal techniques by considering some examples. Thank you.